In section 2.5, we will be just writing more proofs. Some of the theorems will be important, and some of them are just to show you how to write proofs. This first theorem that we're going to look at, theorem 2.4, says all right angles are congruent. That is important. You will use it, and it'll just allow you to a shortcut to prove that two angles are congruent. Notice that this first piece here, this is your hypothesis, this is your given. So where angle 1 and 2 are right angles, and what you're doing is you're trying to prove the conclusion that they are equal. We start off every proof the same way. We add our givens, and here this is a guided proof, so you see that I gave you the reasons, so that should tell you that you should be looking at where your givens are. So here we're going to have angle 1 and angle 2 are right angles. Remember that anytime that I give you a word, you have to use the definition. And if you look at these two statements here, they tell you angle 1 is equal to 90 and angle 2 is equal to 90. You should be asking yourself, well, where did that come from? Or how do you know that's true? And the reason you know that's true is because here I told you that you have right angles. So you have to use that definition. And because I talk about two different things, that's why you can use this definition twice. So here we have the definition of right angle, and then here we're also going to use the definition of right angle. The last step, I have that angle 1 and 2 are equal to each other, and that's going to come from putting together steps 2 and 3, and hopefully you see that that is the transitive property because you have two things equal to the same thing. And there we are finished because we have the last line of our statements is what the proof was. In the next example, it says the midpoint M of AB divides AB so that AM is equal to 1/2 AB. So here is our given. This matches the hypothesis of the proof, and we're trying to prove this formula. This is a good proof to show you how you can use algebra in all of your techniques for solving equations, but I'm never going to ask you to actually use this theorem in a proof. The first thing it's asking for is that you have the given. So with the given, we know that M is the midpoint of AB. And I'm going to abbreviate midpoint. And that's all we have right now. So we have this word midpoint. We know that we have to use that definition, and this is from your drawing conclusions worksheet. So the midpoint means that you break into two equal segments. Here's our diagram. So looking at that, you should be able to draw a conclusion that AM is equal to MB. And that's your definition of midpoint. The next line tells you that AM plus MB is equal to AB. This is something that I would have to give you to help you along the way in a proof. I wouldn't expect you to be able to come with it on your own. I would expect that if I give you this, you should be able to come up with the reason. So if you look at this here, it says AM plus MB is equal to AB. You should be asking yourself, okay, I have segments, I'm adding them together, I'm getting that whole segment. That has to be the segment addition postulate. Now when I look at steps 3 and 4, the only thing that's different about them is that instead of this MB, I have an AM. So I switched out, or I replaced this MB with an AM, and I can do that because I know that they're equal from step 2. The fancy name for when you switch something out or you replace is the substitution property. And then in step 5, it says collect like terms. So you have to have things the same. How many AMs do you have? You have 2. So we have 2 AM is equal to AB. And now I think I'm closer to the end of the proof because in my proof statement, I have an AM and an AB, which is right here. The major difference is that I have a 2 in front of this AM, whereas here it's by itself. And this means 2 times. So the opposite of multiplying is dividing. So if we divide both sides by 2, that's where that 1/2 is coming from. So I have AM is equal to 1/2 AB, and what did I do to get to that statement? I divided. So those algebra skills that we are looking at would have been here, the substitution, the collecting like terms, and then the dividing to solve for AM. Again, this theorem isn't as important as the steps and how you solve the proof in the end. For this proof here, first, this theorem, you can cross that out. You don't need to do that. It's the same as the one we did above with the midpoint. It's just another theorem, and you're not going to use it. This is a better proof for you to see what and how to set up proofs. So the first thing, it says angle 1 is equal to angle 2, and I know that they are equal because it's after the given. We always start every proof with our given. Here now we have angle 3 and angle 4 equal to each other, and that was after the given. So that follows the given as well. And then the next thing, it says vertical. So I know my vertical angles are equal, and then if I look at the diagram, these here are your vertical angles. So that's how I know what the statement is. That's something that would be more difficult to figure out on your own unless you have that diagram. So angle 3, angles 2 and 3 are equal to each other. From here, it's up to you what you see. If it's easier, we know we're using the transitive property. You're going to end up actually using it twice. So the first thing we're going to do, because you can only do it with things that are equal, I'm going to look at steps 2 and 3 because I can see together right now that angle 4 is equal to angle 3 and angle 2 is equal to angle 3. So that means these have to be equal to each other. So I have angle 4 congruent to angle 2, and that's the transitive property. And my goal is to get that angle 1 is congruent to angle 4. Well, I didn't use this line yet, and I have this new line here. So if I put those two together now, 1 is equal to 2, 4 is equal to 2. So using the transitive property again, because they're both equal to angle 2, these two angles, sets of angles, have to be equal. And yes, you have to break it into those 5 steps. You cannot skip just to angle 1 is congruent to angle 4 using the transitive property. All right, last example. This is a good one because it involves perpendicular, right angle, complementary, so it involves a lot of words. The first statement we have is the given. So we have angles 1 and angle 1 is complementary to angle 2. So here's 1 and 2. Angle 1 is complementary to angle 2. Then the reason is the definition of complementary, which we should have been able to figure out that that would come next because that's the only word that we have. And we know that complementary means equal to 90. So I know that angle 1 plus angle 2 is equal to 90. This next piece here is angle 1 plus angle 2 is equal to angle JKL, and that is using your angle addition postulate. Notice I gave you both pieces to that, and that's because I think that's a harder step that I wouldn't expect you to be able to see right away. Next, I tell you that you need to use the transitive property, so I'm going to use the transitive property on these two pieces. Notice I have JKL is equal to angle 1 plus angle 2. I have 90 is equal to angle 1 plus angle 2. They're both equal to angle 1 plus angle 2, so I know that JKL equals 90 degrees. So that's where step 4 comes from. Since JKL is equal to 90, that means it's a right angle. That's why you have definition of right angle here. And I'm going to have to put here in words, JKL is a right angle. And the reason why is because the definition for perpendicular says you have right angles. So somewhere above that, you have to tell me that you have a right angle in words, not in numbers. So now that I know that I have a right angle, now I can say that my lines are perpendicular, and that's your definition of perpendicular. And you can write just the symbol for that. It is very important to know, and this is from your drawing conclusions worksheet and from your 2.3 notes, and from the drawing conclusions quiz. Whenever you have perpendicular, it means you have a right angle, and then from there you have to state that equals 90 degrees. You can't just streamline it and shortcut it to that. From here, you will look at the exercises in the book, and you'll look at the worksheet that you have.